Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The target compound, A, is a bicyclic alpha, beta-unsaturated lactone, specifically a hexahydrobenzofuran 2-1 with a double bond between C3 and C3A, bearing a CH3 at C3. This type of alpha, beta-unsaturated lactone can be formed by an E2 elimination or base-induced dehydrohalogenation of an alpha-halolactone using IChO, ethoxide base. Moving on to the next step. To form the C3 is equal to C3 a double bond in the product, we need a precursor that has a leaving group, Br, at C3 and an H at C3A, or vice versa, Br at C3A and H at C3, positioned in an antiperiplanar arrangement for E2 elimination. Moving on to the next step. Option A shows the bicyclic lactone with H on a wedge at C3A, ring junction, and Br on a dash at C3, along with CH3 on a dash at C3. The H at C3A and Br at C3 are on opposite faces, anti-relationship, due to the transfused ring system stereochemistry shown. IChO abstracts the H at C3 while Br leaves from C3 in an E2 fashion, generating the C3 a double bond and retaining the CH3 at C3, giving exactly compound A. And for the final step. Option B. The stereochemistry of H at C3A and Br at C3 is different, both on same phase S-Y-N relationship, making E2 elimination geometrically disfavored or giving a different product. Option C. The structure has a quaternary carbon, no H on the carbon bearing Br and CH3, so E2 elimination toward C3 is equal to C3 is not possible in the same manner. Also the ring system appears different, possibly spiro. Option D. The configuration at the alpha carbon and ring junction differs such that the required antiperiplanar HCCBr arrangement for E2 is not present, or elimination would yield a different regiochemical stereochemical outcome. Only option A provides the correct stereochemical relationship anti-H and Br at adjacent carbons C3A and C3 needed for E2 elimination with IChO to produce the target alpha beta-unsaturated lactone A with the CH3 substituent. Therefore, the correct answer is A. Therefore, the correct answer is option A.